Okay, so now we will discuss how we can interpret coefficients of logistic regression. Okay, we are having these coefficients here. Let's say our equation usually we were having like this: p cap is equal 1 over 1 plus e raised to power minus, let's say, beta 0, which is intercept, plus beta 1 x1 plus beta 2 x2 plus up to beta n xn. Okay, here we are having 21 sample 21 columns, independent columns, so it will be beta 21 x 21. Okay, so in this way we are having these coefficients here. You can say this is beta 0. Okay, and in this way this is beta or 1, beta 2. In this way you can consider. Okay, so these are the betas, these are the actually coefficients. Now in the same way, if I will write in this equation in the form of logit of p, then it will be log odds p over 1 by minus p is equal beta 0 plus beta 1 x1 plus beta 2 x2 up to, let's say, beta 21 x 21. Okay. Now we have this, we can write equation in both forms. Okay, so now you can have a look here. Let's say this is beta 1 and x1 plus beta 2 x2. Okay, now if this is age, let's say this is age. Okay, x1 is age and beta 1 is 0 minus 0.14. This is minus 0.14. What it actually means, we can say here, keeping all other coefficient, or let's say all other terms are constant at some point, then increase 1 unit in the age, there will be 0.14 decrease in the log of odds. Okay, when you will let's say previously you are having age 27, let's say 27, and if now you have increased 27 to 28, there will be minus 0.14, means 0.14 decrease in this term. Okay, this is actually the coefficient mean here. Okay, uh, normally we will have a look on this in a very detail. Uh, Before that, I hope you got an idea that coefficients have some impact. Let's say, uh, and if I will show you here, this is probability. Okay, when the probability is actually the directly proportional to the log odds. Okay, what is odds? Odds, it's this is odds. It's a ratio of chances. This is chance of getting chance of getting one. Okay, chance of getting one to the chance of getting not getting one, chance of not getting one. Okay, or in other words, you can say chance of getting zero. Okay, so if this term is high, this term is high, of course this term will also be high, means this is directly proportional. In the same way, log of p cap over 1 minus p cap. Okay, in the same way, uh, this term is also directly proportional to the odds. Okay, probability is directly proportional. Here you can say probability is directly proportional to the odds, and odds is directly proportional to the log of odds. You can say here that if probability will increase, then odds will also increase, and if odds will increase, log of odds will also increase. In the same way, if probability will decrease, odds will also decrease, and if odds will decrease, log of odds also decrease. Okay, here you can see probability usually having this range between 0 to 1. Odds have range between 0 to positive infinity. Okay, and log of odds have range between minus infinity to positive infinity, but they are directly proportional. So it means when here the negative sign is showing that when the increase in age, when the age will increase, when the age will increase, our log of odds will decrease. Okay, here you can see our from equation, our log of odds will decrease, and from here we can interpret that our probability will also decrease. Probability of getting 0, sorry, probability of getting 1, probability of being default. Understand? It means when the negative sign is showing here, or when your age will increase, your probability of being default will decrease. Credit amount is positive, have positive coefficient. It means when the credit amount will increase, your probability of being default will increase. And you also know from the ADA part during analysis, you have idea that a higher credit amount, more chances to default, lower the younger customers, more chances to default. And here coefficients are also interpreting in that way. Okay, with the increase of age, there will be decrease in the probability of being default. With the increase of duration, when duration will increase, your probability log of odds will increase. And when your log of odds will increase, your probability of being default will increase. Okay, you can say your by the increase of your duration, your probability of being default will increase. Okay, uh, and here again I will tell you here. This is P over 1 minus P. P is a probability of being default, and 1 minus P is probability of being not default. So this overall we can say these are the odds of being default. Odds is actually the ratio between of the chances. Okay. So odds of getting the ratio of probability of being default to the ratio probability of not being default is actually the odds. Okay, you can say this is the odds of being default, the P over 1 minus P. Okay, now come back here, and we have understand that sign represent how is it has a positive relation with the probability or negative relation with the probability. Now if we want to see how much increase or how much decrease in the uh, probability or in the odds or in the log of odds by increasing some value. Like here, I have shown you when your age will increase, like here 27 to 28, your 0.14 decrease in log of odds. Okay, your 0.14 decrease in the log of odds. Now we will see the impact of 0.14 decrease in log of odds, and we will also see what actually this coefficient is representing here. If we want to just interpret just single coefficient, what this coefficient is saying here. Okay, now you will have a look on that. It's very simple. I am just for you here. I have considered just two. Let's say we have just two independent variables. Uh, Duration and sex male. Okay, so I have given the uh, letters D for duration and M for the male. Okay, we have corresponding this B0 is intercept, B1 is the coefficient with respect to duration, and B2 is the coefficient with respect to the male. Okay, in this way we are having equation 1 or 1 plus e raised to power minus b uh, coefficient into our variables. So if we write in this way, it will be logit of p, and logit of p is log of odds of being default. So we can write in this way. So this is our equation. Okay. Uh, Keeping in mind, I am here considering just two variables, duration and sex male. Okay, now if your duration will increase here, duration will increase, your log of odds will increase because it has positive coefficient. So if your duration will increase, uh, 0.17 will be multiplied with the change in duration, which is here increase, and there will be positive change. So with the positive change, when you will multiply with 0.17, it will be positively increase your log of odds. In the same way, if you will increase male, let's say from 0 to 1, if you will have first you have male is equal to 0 means female, and you now have change it to male is equal to 1, your when you will increase your male, your log of odds will decrease. Okay, because your male has 0.18 negative coefficient here. Okay, so let's say for a while. Okay, let's say here we have this equation, and consider just duration part, just this duration 0.17 into d, and consider other as a constant. Okay, so here and duration, pass the value to the duration is equal to 47, let's say 47. Here you have passed the duration, and the remaining all the terms like this minus 0.19 as it is, 0.18 for the male, and here you have passed the male is equal to 1. Okay, now you have this type of equation here. Okay, now you will increase the duration from 47 to 48. You will see here now you have 0.17 into 48. Okay, all the remaining terms should remain constant for a while. Okay, so that we can see the impact of coefficient, durations coefficient. Okay, coefficient which is of duration. So when 40 from 47 to increase 48, there we will see how much increase in log of odds. You will simply subtract the log of odds when you have duration 48 minus when the duration is 47. These terms are constant in both cases. In both cases, 0. Minus 0.19 minus 0.19 plus minus 0.18. Okay, and plus this 0.17 into 48. I will zoom out here. Okay, and here minus constant plus 0.17 into 47. Okay, now you have this 0.17 here. It means when you have changed your duration from 47 to 48, your increase in log of odds is 0.17, and you can directly see from your coefficient it actually interpret in this way. When you will increase your duration by 1 unit, your increase in the log of odds will be 0.17. It is very simple. Okay, now if you will write this log of odds in the form of let's say this this is actually the difference, and you know the property of the log, let's say log a minus log b is equal log of a by b, you can write in this way. Okay, so if you will write this in this way, a log of odds by odds, log of odds ratio, you can write in this way. Now you can say your coefficient is here 0.17 is the is represents the log of odds ratio. Log of odds ratio. It actually represents the log of odds ratio. Okay. So now you can see by increasing 1 unit in duration, 0.17 increase in the log of odds, and odds you have here. Uh, odds means odds is actually p by 1 minus p. Okay, so this is this one. If you want to write this, this is log of odds. Odds p over 1 minus p over 1 minus p, and this p over 1 minus p when the uh, let's say when duration was 48 and when duration was 47. Okay, so here you can see this 0.17 it's actually the log of ratio, odds ratio. Okay, 0.17 is representing here. Okay, now if you will have this in terms of log, if you will remove the log, which is actually the natural log here, natural log, of having base e. Okay, if I will write in this way, natural log usually write in this notation, it has actually the base e. When you will remove the log, you will have other term on the other side will on the power of e. Okay, now here you can see when you have taken your coefficient which was 0.17 uh, and you have taken the power of 0.17 to the e raised to power 0.17, it is giving you the 1.19. Okay, so 1.19 means odds ratio. Okay, 1.19 is representing here odds ratio, or in other words you can say e raised to power your coefficient e raised to power 0.17 is odds ratio, is odds ratio. Okay, we are having here odds p over 1 minus p. Okay, and p is probability of being default. I have told you this multiple times. Okay, so now we want to see, here is a question: how much percentage increase in odds when our duration is increased by 1 unit? Let's say when our duration is increased from 47 to 48. Okay, how much percentage increased in our odds? Okay, if we want to see that, so it's very simple, 1.19 and minus 1. Okay, so then multiply by 100, there will be 90% increase. Okay, now we can say 19% increase in the odds by increase 1 unit of duration. Understand? This is actually you can in this way interpret your coefficient. Your coefficient was 0.17 and you got an idea 0.17, it's actually the log of odds ratio. Okay, and if you want to see the odds ratio, then it will be e raised to power, odds ratio will be e raised to power 0.17. Then if you want to see how much percentage increase in your uh, odds, in your odds by increasing 1 unit in the corresponding predictor variable, you can use e raised to power 0.017 minus 1 into 100, it will give you some percentages. Okay, in this way you can interpret. Now you can say the 19% increase in the odds by increasing 1 unit of duration. Okay, and for very simplicity, you can say in the simple way that this is the equation that you are having previously. When your duration will all the remaining variables coefficient all the remaining variables should at if constant at some particular value, then if your duration will increase by 1 unit, your log of odds will increase by 0.17. It is obvious, okay. Now you can see this 0.178, it's actually the log of odds ratio. You are also have got an idea about that. And if you want to see how much percentage increase in that odd in that odd p or 1 minus p, how much percentage will increase by increasing 1 unit in duration. So you can use by very simply e raised to power 0.17 minus 1. This will give you the percentage, how much percentage will increase in your odds. Okay, now we have considered duration. In the same way, if you will consider the male column, okay, let's say for a while you can consider male column. This is the equation, the same equation. This is the intercept, this is the coefficient for duration, this is the coefficient for the m column. Let's say you are having male is equal to 0. Let's say you are having male is equal to 0, and this is constant at some particular let's say these constant at some particular values 47. Let's say 47. Okay, now when your sex male is equal to 1, then it will be in this way, and our remaining terms will be constant at, let's say this is constant at some particular value 47, and you can also write this in 47. Okay, now when you will see the difference in the log of odds when you have changed the category from 0 to 1. Okay, when you have changed your category from 0 to 1, this is the logo force when the category is of 1, male is equal to 1, and this is the category when male is equal to 0. In other words, this is the case when you are your customer is male, and this is the case when your customer is female. Okay, so here you will see constant plus minus 0.18 minus constant, and this in the case of female there it will be become 0. Okay, because of male is equal to 0, m is equal to 0. So here you can see minus 0.18. Okay, when you will change or you can say female to male. Okay, when you will change your customer let's say previously your customer was female, now the your customer is male, then how much decrease in minus is showing decrease, your log of odds will decrease by 0.18. Okay, or you can say probability of being default will increase will decrease when your customer will male. When your customer will mail, your probability of being default will decrease. Okay, so in the same way like we did in the case of duration, we can interpret our coefficient in terms of odds ratio. Okay, so here it is in terms of log of odds ratio, and if we will move this log on the other side, it will become odds ratio. Here you can see odds ratio, it will become odds ratio when you will take e raised to power minus 0.18. Here you can see this is 0.84. It's a ratio of odds when customer is male to the odds when customer is female. Okay, you can say this 0.84, it is actually the of odds ratio of odds. Here we can write in the odds, instead of odds I will write properly p by 1 minus p. Okay, and divide by p by 1 minus p. Okay, this is p when male is equal to 1 when customer is male, and this is when customer is female. Okay, so 0.84, it's actually this one, ratio of odds. Okay, so you will see when you will see this in the form of percentage, let's say e raised to power, sorry, 0.84 minus 1 into 100. Okay, so how much will decrease in here? Here is percentage is minus 16%. Okay, so it means 16% decrease in the odds of being default when your customer will be male. Okay, you can interpret your coefficient in this way. Okay, so here in a very simple way, if you will interpret from here, let's say this is log of odds, which is p over 1 minus p, is equal minus 0.19 in sorry, it's a coefficient, plus 0.17 into d, which is duration, minus, here I will minus 0.18 into male. Okay, so male is a binary column and D is a continuous column. Now here you can see, let's say it is constant for a while. Now if your male is equal to 0, it will remain as this term will be, the whole term will be 0. And then if this m is equal to 1, then this minus 0.18 will be here, and it will decrease this, okay, by 0.18 log of odds. Okay, means when your customer is male, your decrease in log of odd will be 0.18. When your customer is male, your decrease in log of odds will be 0.18. And you can also say when your customer is male, 16% decrease in the odds of being default. Okay, in this way you can interpret your coefficients. So here, mm, okay, so we were having here we have considered just two variables, duration, and second one was the sex male. Okay, two columns we have considered here, and corresponding two columns we were having two coefficients, beta 1 and beta 2. Okay, here you can see this is beta 2, which is minus 0.1, and it's actually if I will ask you what this coefficient is here, it you can say it's a log of odds ratio. If I will ask you what odds ratio, you can say log of odds belonging to defaulter when person is male, when person is male, or odds belonging to defaulter when person is female, the ratio of both odds, and then you will take a log of odds ratio. Okay, this will become 0.18 minus 0.18. Okay, you can say that minus 0.18, it's actually the log of odds ratio, actually log of odds ratio. And if you want to see the odds ratio, you can simply take a, a e raised to power minus 0.18. It will tell you the odds ratio. And if you want to see the percentage change in odds of being default, then you can use this formula, e raised to power coefficient minus 1 into 100. It will tell you how much percentage is increase or decrease in the odds. Okay, so these are the coefficients that we are having. These are the estimated coefficients that our during training our model has calculated. uh, Best fit parameters or best fit coefficient, you can say. These are the we can say these coefficients are the expected change, increase or decrease in the log of odds, the log of odds being defaulted for a unit increase in the corresponding predictor variable. If duration, then we can say unit increase in the predictor variable, and if it is male column, binary column, then we can say when the when the male is equal to 1, how much will be increase or decrease in our uh, log of odds of being default. Okay, holding all other predictor variables constant at certain value, then we can say that this coefficient is representing this at this particular point. Okay, in this way you can interpret coefficients of logistic regression, and you can also use that analysis of to analyze which column has which type of relation with target column. Okay, you can interpret all here in this way. Okay, here all this coefficient, let's say now you will consider this housing own. Okay, this housing own. Now you can say 0 point minus 0.22. It's when your housing own is equal to 1, your decrease in log of odds will be by 0.22. Okay, and if you will take a power of e raised to power minus 0.22, you can get an idea how much what is the odds ratio at particular point. And if you will minus 1 from that odds ratio into 100, you can see how much percentage decrease in the odds of being default when the housing is out. Okay, and you can also see from the sign that when housing own is equal to 1, then there will be less chances of being default. And from the analysis that we have done in the EDA, you know, when the houses is equal to own, there is less chances of being default. And when the housing is equal to rent or housing is equal to free, then there are more chances to default. Okay, here we have two categories. Housing is equal to own, housing is equal to rent, and the third is housing is equal to free. Okay, so here you can see housing is equal to free can be used as a reference. Okay, means 0.22 means when from housing free to housing own. Okay, uh, when you have let's say when previously when you have housing free, customer have housing free. Okay, now there is another customer who has housing who has own house, then you can say this the customer who has own house has 0.22 less log of odds compared to the person who has free house. Okay, house free you can use as a reference. In the same way, you can compare for the rent of house. Housing rent means here 0 minus 0.004 means 0.004 your log of odds of a customer who has who has rented house has log of odds 0.004 less than the customer who has free house. Okay, in this way you can interpret. And for if I will show you here. Okay, okay, here are coefficients, and if I will take e raised to power these coefficients, I can see how much uh, I can see the uh, you can say odds ratio. Okay, change in odds, so you can see how much the change in odds actually instead of log of odds. Okay, here you can see coefficients. These are the log of odds. If we will take e raised to power coefficients, it will become odds ratio. And if we will minus 1 from odds ratio and multiply by 100, it will give us a percentages. And you can interpret here any let's say this is 0.44, means 0.44% decrease in the odds when a customer has rented house as compared to the person who has free house, housing free. Okay, in the same way you can let's say in that particular case you can say 0.41 decrease in odds when person has saving account moderate compared to the person who has saving account little. Okay, so in this way we can interpret our coefficients. So you now got an idea why I am taking here odds ratio and changing odds ratio just to for the sake of interpretation, for the sake of analysis. Okay, and you can also see from here the relation of independent variables with your dependent column, which is probability of being default. Okay, now I will start from here of where okay, from finding the coefficient part. Okay.
Okay, so till now we have trained our model, and we also have figured out how we can interpret our coefficients of logistic regression. Okay, so here we are having coefficients, model dot coefficient, and if I will here I have created an instance of coefficients log of odds ratio, and because I know that coefficients are actually log of odds ratio. Okay, model dot intercept, this is intercept, and here I have created a uh, data frame. Okay, now I will interpret my coefficients just with respect of signs. Okay, so I know the coefficient which has negative sign, it means it has negative relation with the target column, and which has positive sign, it means it has positive relation with our target column. So here I can say that coefficient of credit amount, duration, and some categorical levels of purpose are positive. So if they are positive, so an increase in values of these variables, or if it is categorical, then if we will make that variable equal to 1, then this increase in the value will lead to an increase in the chances of customer being default. Okay, so the coefficients which are negative we can interpret in this way. Coefficients of age, sex, male, housing, saving accounts, checking account, job, and some categorical level of purpose are negative, so an increase in values of these variables will lead to an decrease in chances of customer being a defaulter. Okay, in this way we can interpret our coefficients. Now for the interpretation of the strength of the relation with the target variable, we have learned odds ratio and the change in or you can say percentage of change in odds. Okay, so coefficient of logistic regression, we know these are log of odds ratio. If we will take these coefficient as a exponential of e, then it will become odds ratio. Okay, odds ratio, let's say in the case of male, we can say e raised to power 0 minus 0.18 will be the odds ratio. What will be the odds ratio when odds when the sex male, when the customer is male, to the odds when the customer is female, is e raised to power minus 0.18. Okay, so here I will create another row here, or you can say it's a transpose. So we can say I will create another column, okay, here, which is odds ratio, and all the coefficients are e raised to power coefficients here are the values. Okay, so these are the odds ratios. Okay, so if I want to see how much change in odd, okay, percentage, in terms of percentage, if I will use this e raised to power b minus 1, then it will be a change in odds, how much change in odd by changing the coefficient, by changing the some 1 unit in the increase of the corresponding predictor variable, keeping all the other variables value constant at some particular value. So this will be change in odds. So when I will multiply that change by 100, it will give us the percentage change in odds. Okay, so I have created another column, and I have here change in odds. Now, what will be the advantage of that? I can see now the strength of the relation also. Let's say here this minus 13.8, it means that when uh, an increase in 1 unit of age will decrease 13.8% odds of being default. Okay, in this way we can interpret each coefficient. Okay, and also we can compare the coefficients or relation strength of the relation with other variables, like the out of all variables, if we will see this is minus 99. Okay, about 20, this housing own has about 20 uh, correlation with the target column. It means that when the uh, when the house when a customer has own house, then there will be 20% decrease in the odds of being defaulted compared to the person who has free house. Okay, so in this way we can say that this housing own is very important out of all columns, because it has a stronger relation uh, with the target column. Okay, so you can see from here 19.9, about 20% will decrease in odds. And one another concept that I have told you, that if like here we have k minus 1 categorical columns against each categorical column. So housing rent, own housing rent and housing free, we not have here, and it will be considered when both housing own and housing rent variable values are zero. Okay, so we will use housing, which column is not here, which is housing free, as a reference. Means 20% decrease in odds when the house a person has own house compared to the person who has free house. In this way, 0.44%, the person who has rented house have 0.44% less odds compared to the person who has free housing. Okay, in this way you can interpret that. Now, another important concept I will discuss here. First of all, we will see here, we will interpret our coefficients like age have 13.83% decrease in odds of a customer being a defaulter by increasing the age by 1 unit, holding all other features constant at certain value. Okay, now keep in mind here, increasing change in age by 1 unit means this age column is we are having scaled. Okay, we have done here standard scaling on these continuous variables, age, credit amount, and duration. So age is now in the form of scaled. It is scaled column. Now change in 1 unit does not mean that change in 1 year. Change in 1 unit mean it is in the form of scale. So it will be standard deviation. One standard deviation change in means 11.25. Okay, so it means if 13.83% decrease in odds of a customer being a defaulter by increasing the age by 11.25 years, holding all other features constant at certain value. Okay, because we have scaled column here, scaled age column. Okay, that's why 1 unit will be one standard deviation. Okay, in the same way, you can interpret credit amount, duration, sex male, odds of male customer being a defaulter is 16.49%, 16.49% uh, lesser than the female customer, holding all other features as constant at some certain value. Okay, housing odds of a customer who has own house being a defaulter is 19.97% lesser than the customers who has free house, and odds of a customer who has rented house being a defaulter is 0.44% lesser than the customer who has free housing. So free housing will be used as a reference here, holding all other features constant at a certain value. In that way we can interpret our coefficients. Okay, So I have here coefficient. I know these are log of odds ratio. If I want to see the odds ratio, I have taken e raised to power that coefficient. If I want to see the change in ratio in terms of percentage, so I have used that formula. Means e raised to power odds ratio. Odd ratio minus 1 into it will give odds ratio minus 1 will give us the change in the odds. When I will multiply that change by 100, it will give in the terms of percentage. Okay, I hope you got an idea. Uh, uh, by interpretation of coefficient, we can also interpret the strength of the relation of particular variables with the target column. Okay, so here you have seen very well. Okay, so now we will go towards the reason why we have used the scale data set. Here in when we have used scale data set, 1 unit is does not mean that change in 1 year. It means change in 11.25 years. Okay, why I have used that? There is a reason. First, I will show you without scaled data. If our continuous columns are not scaled, I have done here inverse transform. Uh, I am like inversing my transform here, and now I will use my I will train a model on the unscaled data set. Okay, that original data set we are having, and then I will interpret my coefficient and how we will look at that. Now here you can see coefficients are become lesser here. Okay, so this 0 point tetra 047 coefficient, credit amount has a coefficient, and in terms of change in odds percentage, it is 0.004%. From here you can say that this credit amount has a positive relation with the target column, but very low positive relation. Okay, you can interpret in that way, but actually it's not. Okay, it is this 0.004, the very less change, very small number of that change in odds ratio for credit amount is due to the unscaled data. Credit amount has very high values in its column, and model usually when you will train your model give the parameter values for the columns that have higher values, smaller coefficients, so that it cannot cause the biasness in the model due to higher values. Okay, so that's why model give smaller coefficient to that particular variables coefficient. So it does not mean that this column, this correct amount has lesser relation with the target column. Okay, so this is an disadvantage of using unscaled data. You cannot interpret your coefficients very well. Here you can see it means 0.004% increase in odds when your credit amount increase by 1 unit, and here 1 unit will be 1 dm, 1 Deutschmark. But in the case of scale data, here you will see that credit amount is increased 11.53% when your credit amount increased by 1 unit, and here 1 unit means when your credit amount increased by about 3000 dm Deutschmark, holding all other feature constant. And in the case of unscaled data set, you are interpreting here that 0.0047% increase in your credit amount when your credit amount will increase by 1 dm. Okay, but here also in our column, in our data set, there is not the increase in credit amount by 1 unit. There are persons are increasing credit amounts by the if the standard deviation is 3000, then on the average difference in typical customer credit amount with another customer credit amount is about 3000. Okay, because standard deviation is 3000, is it means that there is a difference, there is a deviation in our samples is about 3000 in the form of credit amount. Okay, so that's why for the sake of coefficient interpretation, we have used scale data set. Okay, we have not used the scale data set for the performance of model. We have used scale data set here for the you can say more accurate coefficient interpretation. Okay, so that we can do analysis of the strength of the coefficient, strength of the variables with relation of the variables, independent variables with the dependent variable. Okay, so uh, when will use the scale data set, then it is easy to compare the impact of that particular variable's coefficient with other variables when data is scaled. Okay, so okay, now till now we have seen, if I will start from the above, we have seen that we were having data set. Then we have transformed our categorical columns to categorical columns to numerical columns. Okay, we have done some pre-processing on our data set. Then we have splitted our data set into train and test data set. Then we have done standard scaling to bring all the other continuous features on the same scale, and although other categorical features are already in the form of 0 and 1. Then we have done hyperparameter tuning so that we can get the best parameter values, for our model that we have to use here for the logistic regression. Okay, then we have trained our model, and after training of model, we have find out the coefficient. Then we try to interpret our coefficients in terms of odds. Okay, how much increase or decrease in odds by increasing or decreasing in the particular value of some particular variable, keeping all other variables constant at some certain value. Okay, so we have done the coefficient interpretation, and we also have seen the impact of the unscaled data set on the interpretation of coefficients. Okay, we have seen the reason why we were using scale data set. Now we will see the performance of our model, how we can evaluate our model, how good our model is that we have trained here.